Ah! Okay. So according to Wikipedia, a laser is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. So the word laser itself is actually an acronym. In case you were unaware, it stands for light amplification by stimulated emission of radiation. So in plain English, a device can be classified as a laser based on the way it produces the beam of light, which is a method called stimulated emission. So over the next hour and a half, we're going to talk about the history. No, it's not an hour and a half long. That would suck. No, but before we delve into what exactly stimulated emission is, let's move over to the place where we go to learn about the history of things. The concept for the laser was thought up back in the day by a pretty famous scientist. I'll give you a hint. Einstein. Dang it. Yeah, so Einstein published a paper titled On the Quantum Theory of Radiation back in 1917, and in his paper he established the theoretical foundations for the laser and maser. The maser is actually the same thing as a laser, except it uses microwaves instead of visible light. Einstein theorized that if you had a collection of atoms in an excited state, meaning that each one just had more energy than it would under normal circumstances, that you could fire a photon or a particle of light through those atoms and it would stimulate them to each release photons of their own in the same direction. Okay, so for instance, if I were an atom, no, not my name, no, like if I was an atom, and saw the photon flying by, I would be all like, hey now, that's a great idea. I think I'll shoot off the same color photon in the same direction. Pew! And if there were a lot of these excited atoms, this would start a chain reaction producing lots of photons. And this is the process called stimulated emission, and is the idea behind how all lasers work. So to better understand what stimulated emission is, let's real quickly talk about how a flashlight produces a beam of light, and then we'll compare. Inside of most light bulbs, you'll find a thin wire called the filament. When you turn a flashlight on, you pass an electric current through the filament, which heats up and begins to glow. Welcome to my bathroom. I don't know why we came in here. Ooh, a penny! Now, most flashlights have a reflective surface that surrounds the bulb, and its purpose is to focus the light into a steady beam. Lasers, on the other hand, produce that narrow beam because all of the light waves have the same phase, frequency, polarization, and direction of travel. In other words, all of the waves are waving in the same direction and they're all the same color. Well, I have this laser pointer right here, and based on what we already know about lasers, how does this thing actually work? Okay, typical lasers like this one all have the same basic components. The first is called the gain medium. It's those excited atoms that we talked about a little earlier. The second is called pumping energy, and in this case, it's the electric current supplied by the batteries that are inside of it. The third component is called the high reflector, and it's just a mirror that sits at the back of the laser. And the last thing is called the output coupler, and it's just a semi-transparent mirror that sits in the front of the laser. In the case of this laser, it's about 2% transparent, which means that if you were to shine a light on it, it would reflect about 98% of the light back to you and only allow about 2% to pass through. Alright, so now that we know the stuff that's used to make the device, how does it actually produce the beam? Well, the answer, of course, is magic, duh. Nah, I'm pretty sure it's not magic. I am 29 and stuff, so I probably ought to know. Alright, so when you press the button, the battery releases an electric current that supplies energy to the atoms in the gain medium and puts them in that excited state that everybody's all buzzing about. The excited atoms begin producing photons of light, which trigger the chain reaction that we called stimulated emission. Now, once this happens, all these photons are just bouncing back and forth between the two mirrors inside of the device. And each time a photon crosses the gain medium, it stimulates the production of more photons, which start bouncing back and forth, and on, and you get the idea. So now the way the beam actually ends up making it out of the device is because of that semi-transparent front mirror. So even though only about 2% of the light is escaping at any given time, it's still pretty intense, which is why you're not supposed to look directly at a laser or shine it into anyone's eyes. Side note, shining one of these lasers at an aircraft is a federal offense in the United States. That's extreme. So there you go. Lasers are pretty cool. We found plenty of ways to use them that have really revolutionized the way we operate as a society. I mean, think about it. Star Wars, Star Trek, the Death Star. You can point at stuff on a wall with laser. You can mess with your cat. Yeah, that's pretty much it, I think. Oh, Pink Floyd made a laser show, right? A laser show? I don't know.